Your wrinkled fingers are not a malfunction. They are a grip upgrade your brain activates on purpose. Spend 5 minutes in a bath, and your fingertips transform. Deep wrinkles appear across every finger and toe. For over a century, scientists assumed this was simple osmosis, water soaking into the skin, causing it to swell and buckle. But in 2011, a discovery changed everything. Researchers found that people with nerve damage in their hands do not wrinkle at all. The wrinkling is not a passive reaction. It is an active signal from your nervous system. Your brain is choosing to wrinkle your fingers. And the reason why reveals something remarkable about human evolution. The wrinkling process begins in your sympathetic nervous system, the same system that controls your fight or flight response. When your fingers detect prolonged water exposure, sensory nerves send a signal to your brain. Your brain responds by triggering vasoconstriction, narrowing the blood vessels beneath the skin of your fingertips. As blood flow decreases, the underlying tissue shrinks slightly, but the outer layer of skin, the epidermis, stays the same size. The mismatch between the shrinking tissue below and the unchanged skin above creates the characteristic wrinkled pattern. This is not random. Brain scans show the wrinkling follows the same pattern every time because it is controlled by your nervous system, not by water absorption. In 2013, researchers at Newcastle University conducted a landmark experiment. They asked participants to pick up wet marbles with dry fingers and with wrinkled fingers. The results were striking. Wrinkled fingers picked up wet objects 12% faster than smooth fingers. The wrinkle pattern works exactly like tire treads on a wet road. The channels between the ridges act as drainage ditches, pushing water away from the contact surface and increasing friction. A 2014 study using 3D surface mapping confirmed that finger wrinkles form a mathematically optimal drainage network. The ridges are not random. They follow the same branching pattern seen in river deltas and highway drainage systems. If wrinkling is an active process controlled by the nervous system, it must have been selected for by evolution. The leading theory suggests that our ancestors who developed this response had a survival advantage. They could grip wet rocks when crossing streams. They could handle tools in the rain. They could climb wet trees to escape predators. This adaptation likely evolved millions of years ago, when early primates still lived in forests with frequent rainfall. Macaque monkeys also exhibit finger wrinkling in water, suggesting the trait predates the split between humans and Old World monkeys, roughly 25 million years ago. The fact that our toes also wrinkle supports the locomotion theory. Wrinkled toes provide better traction on wet surfaces, just like the tread on running shoes. Despite the evidence, the wrinkled fingers story is not fully resolved. A 2014 study in Germany failed to replicate the grip advantage, finding no significant difference between wrinkled and smooth fingers when handling wet objects. Some researchers argue that the vasoconstriction is simply a side effect of the nervous system detecting water, not a purpose-built adaptation. And one major question remains unanswered. If wrinkled fingers are better for grip, why are our fingers not wrinkled all the time? The answer may involve trade-offs. Wrinkled skin has reduced sensitivity to fine textures. Studies show that wrinkled fingertips are worse at detecting subtle surface features. So your brain appears to maintain smooth fingers for precision touch and only activates the wrinkle mode when the grip advantage outweighs the sensitivity cost. Your fingers are smarter than you think, and science is still uncovering their secrets. Subscribe to Curious Science for more answers hiding in plain sight.